Over the semester, we have learned much about the greater sage grouse, including the fact that they are an important species when attempting to conserve natural sage-grouse steppe areas. And in order to maintain these habitats that sage grouse rely on, there's been several management strategies to be implemented, including prescribed burning. And this is kind of what my group is going to focus on today, and not necessarily prescribed burning, but just fire in general. Some research has found a positive correlation between increasing fire size and luck abandonment, and this makes sense as it's creating a different ecosystem dynamic, as with previous historical fire regimes, sage grouse habitat experienced fire return intervals of 12 to 24 years. Fire has a variety of effects on sage grouse because the grouse depend on so many different plant community types, and the fires are going to affect these different communities in a variety of ways. So for example, they need riparian habitat for rearing their young, and they need big sagebrush for winter food, and then they need sparsely vegetated areas for lekking. This also demonstrates why conserving habitat for sage grouse by default also saves habitats for a lot of other species, as you're going to be covering all the bases with such diverse habitat needs. But getting back to fire has been specifically used as a management strategy for juniper woodlands and to recover herbaceous vegetation shrubs. However, this type of fire can also eliminate sagebrush, which we discussed already is important for sage grouse nesting, breeding, and feeding. However, the type of fire that will remove the juniper and also, unfortunately, the sagebrush can create an open area with sparse vegetation, which we know is ideal for lekking sites. Therefore, we believe that the effect of fires may cause an increase in lekking sites, while studies like the one that found a correlation between fire size and luck abandonment that I mentioned earlier, our group believes that moderate fires may improve sites over time, and rather than studying the immediate effects of fire on lekking sites, we wanted to look into the long-term regeneration after a fire. So we did this by assessing the vegetation effects of burn scars and male abundance at lekking sites over several years. Our hypothesis being that if a moderate fire creates an open area for lekking displays, then the male populations will increase over time at these sites. Again, this wouldn't be an immediate change, as the greater sage grouse depends on the regeneration of sagebrush for nesting and foraging. But over time, as the sagebrush returns and clear areas remain for lekking, the ecosystem may be able to better support the diverse communities that sage grouse rely on to thrive.